Hello everyone. In this video we're going to provide an introduction to Building Information Modelling, or BIM as it's more commonly known, in the context of civil and structural engineering. So we will be covering theory and what BIM actually is, its advantages. Another component of it is the common data environment, and also its BIM documentation, which is something that you will come across in your careers. So the first place to start is to actually understand what is BIM. So BIM stands for Building Information Modelling. BIM is a process and includes a digital representation of a building's physical, functional properties and the characteristics in the form of a 3D model. So it's more than just the building's appearance, and it includes information on all the components within the project. So each component is a BIM object in itself. As we can see from the screen here, we have a structural model, a fire protection model, a plumbing model, an electrical model, mechanical model, and an architectural model. All these are brought together to create a federated model. And in an ideal world, basically all the different stakeholders in the construction project will have access to this model and see the differences or the changes made to this model in real time. So bringing this into an Irish context, we'll have a look at the BIM model for the Children's Hospital. So we'll see here on the left of the screen we have a site plan. Obviously this was created by the surveyors before the building construction started. Then we have the structural plan, which is put together by the structural engineers. We do the internal plan, which is, this could be part of architectural stuff. We have the landscape plan. We have the M&E plan. So M&E is mechanical and electrical. So this would be all your electrical circuits, your wires and all that type of thing. And then the overall building envelope. What happens is all these models are created separately to a certain degree by different disciplines, and then they're brought together into a container file that shows the entire model together. One of the common things that people get wrong about BIM is to assume that BIM is actually a software suite. You see people, they go into an office and they see the nice 3D models, very complex models, and they assume that the software being used is the BIM software. Well, that obviously isn't correct. So BIM is actually the process, as we mentioned earlier on, and we'll go through the process in other lectures. But software like Revit and all the different software we see here on the screen used by different disciplines, they are actually BIM tools. So you're going to be using Revit in this module. So that Revit is a BIM tool. BIM is not the software. Using these different types of softwares, again, it's different softwares for different disciplines. So the mechanical, electrical might have their own discipline or their own software. The architects might use a different software. There's different ones you can use. Within TU Dublin, we're in the Autodesk ecosystem, especially in the civil and structural. So you will be using Revit and its Autodesk products. There are different Autodesk products that can be brought into it. If you are looking at it from a structural point of view, you can bring Revit models into a software called Robot, where you can carry out structural analysis. You can bring it into another Autodesk software called Navisworks, which we'll be doing in BIM 2 next semester. That's when we can actually bring in different models and see how they clash together. But we'll cover that again in a bit more detail. But using all these different softwares, whether it's SketchUp or different things, what it does is it creates the production. It basically helps us produce a reliable and coordinated model with coordinated documentation. Nice data-rich virtual 3D model, which we can all look at and see how it looks. And there's usually like a single database for all the vital design information, and then this would be used by all the stakeholders throughout the project's life cycle. Again, it does make things a lot more efficient than what the old-fashioned way of doing it. So what we're going to look at next is what are the advantages of actually using BIM for your construction project, as opposed to the traditional way, which didn't rely on the BIM process. So on this screen we see, it's a common graphic you'll see when people start talking about BIM, but it highlights one of the key things I think that BIM actually helps people with, especially during these big construction projects, and that's better coordination. So we'll see on the left hand side here, we have the different stakeholders. So we have the architect who designs the building, the client who obviously wants the building, who's going to own the building afterwards, the facilities manager and finance manager. We've got the engineer, or the engineers, could be the case, and then the contractor who's actually going to do the construction work. As we can see here, when each of these different stakeholders want to talk to each other, they have the possibility to talk to each other individually. And again, this can cause some confusion. Again, if anyone's ever seen any house building shows on RTE, the Room to Improve, I think it is, the issues come across when the client starts talking to the contractor without the architect's input, or just the architect starts talking to the contractor and the client isn't aware of what's going on. What happens here is that you have a bad coordination, bad communication, and that just can lead to confusion, delays on site, and this can snowball into bigger issues like cost and all this type of thing. Where using BIM, we can actually improve that coordination. So on the right hand side here, we'll see in the center, we have the live BIM model, which from our previous slides would have been called your federated model. And all the architect, the client, the facilities manager, the different engineers, and the contractor can all in theory work on the same model. So if the client has some changes they want to make, they can notify the architect, and the architect can then go in and change the model, and those changes can be seen almost in real time. Again, this is the ideal BIM situation. The software isn't there just yet because it takes a lot of buy-in from all different contractors and stakeholders, but everything is slowly moving in this direction. But even still at the moment, using the kind of centralized model between architects and engineers is still something that's going to improve the coordination. So again, this helps. It's better coordination for the design documents of the building. And again, this actually ties into other areas we can help. So it's better RFIs, or an RFI is a request for information. So this is a business process used in construction to request clarification about documents, drawings, specifications, and other projects conditions. So for example, if the contractor needed a set of drawings, in the olden days when I used to work as an AutoCAD technician many years ago, not that long ago, well, a little bit maybe, but what happened on the day, what would happen is the architect would send changes they wanted to get made. That would be an email sent to the structural engineer in the office I was working in. The structural engineer would make some changes. That would go to me as an AutoCAD technician. I'd draw up those changes on the plans, issue those drawings, they get signed off by my manager, and then they'd actually have to be faxed or posted back out to the contractor, or a lot of the time I was told to get in my car and drive back out to the site with the printed drawings to show the contractor on site. And occasionally then what would happen is we'd get those drawings to the site and the architect would come back and say he's actually not happy, so we'd have to do the process again. And sometimes you're going a bit back and forth. And again, the bigger the project, the more complicated it can be. So when people are looking for requests of information, like the architect is looking for a particular detail or the contractor is looking for a particular detail, in the old uncoordinated method, it involves someone, possibly like me, back as an AutoCAD technician, driving around, editing drawings, printing stuff off, giving it to one person. The other person might not have the most up-to-date drawings. So it really was an inefficient process. It was the best we could do at the time before the internet was really, high-speed internet was actually there and the software had been developed. But now with the BIM model, all that messing about in the middle, going between different stakeholders, in theory, once you move into a full BIM process, that will be eliminated. Again, that can only make things a lot more efficient. So just to reiterate what we did on the previous slide, it's a bit more of a detailed showing of the coordination. So on the left-hand side, we have our information chaos, and it is chaos because you can see all the different stakeholders like the architect, the building owner, contractor, project manager, and all the little blue arrows, they show all the different ways each stakeholder can talk to each other. It's a very complicated process, and someone's going to miss out on something somewhere, or this process of getting everyone to know something is just going to be a bit long-winded, and it's prone to error. So that's what your information chaos. Using the shared model or the BIM model or the federated model, you'll see here the amount of blue arrows are completely reduced. So everyone should be working on a shared model. And again, this is better visualization and communication between the stakeholders and much better connected workflows between everybody. So following on from the previous two slides, again, it's going to lead us into a new term that we're going to be using quite a lot. It's called a common data environment. So we'll see on the left here, we have the traditional sharing information, which is what was the information chaos from the previous slide. And on the right-hand side, we have the nice shared coordinated model. This is what we call the common data environment. Again, that shared model that we talked about in the previous slides, what we actually refer to that in real life is going to be the common data environment. So this is a cloud-based system where information is collected, managed, and disseminated through a managed process. Again, it just makes everything a lot more clear. Everyone has this access to this common data environment, but if you have got permissions, of course, and then it makes the whole process of the construction a lot more coordinated. So within the common data environment, we usually have documents. This could be the models or the actual schedules and different things. But there are 4 states that these documents can actually be in within the common data environment. Again, this just makes it clear for those using the common data environment what is the most up to date and what parts of the document or what parts of the model and things they should be using. Because obviously you have different stakeholders putting information in there at different times. Some of the stuff's going to be up to date, some of it's going to be work in progress. You need a way to actually coordinate that so people are using the correct stuff. So the 4 states that a document can be in are work in progress, shared state, published state, and archive state. So work in progress state is self-explanatory. So the work in progress state is used for information while it's being developed by its originator or task team. This container file is in this state and should not be visible or accessible to any team apart from its originator. The next one would be a shared state. The shared state is used for information that has been approved for sharing with the appointing party or with other appointed parties or task teams. A container in this state should be visible and accessible to them, but should not be editable. If editing is required, the container should be returned to the work in progress state. The next one is the published state, which is used for information which has been authorized for use, either in the construction of a new project or in the operation of the asset. And the final one is the archived state. So the archive state is used to hold a complete record of all superseded containers that have been shared, published during the information management process. Superseded means that it's actually been replaced by something else. So if you have a version 1 of a drawing and then they come along and make some change and you've got a version 2, version 1 then is superseded and then put into the archive state. So it just means that when people go looking for information, if there's an archive state, they know not to touch that because it's already been replaced or superseded by another one. One of the main advantages of using the BIM process, in theory, of course, is cost savings. So 30% of the cost of construction is wasted in the field due to coordination errors, wasted material, and labour inefficiencies. Again, these points go back to our previous slides about the information chaos. So that coordination errors can lead to different things being wasted, like materials being wasted and labour inefficiencies. So say if the contractor has the plans, he's going to be building a wall and he knows the foundation, knows exactly what he's got to do. He's going to get the labour, or he or she's going to get the labour onto the site to do the work. But then in the background, if the architect and the client decide to change something and then that wall is not going to be there anymore, and then the contractor only hears about it the day of the construction starting, then all of a sudden they've got a team of labourers who aren't actually needed for that day. That's labour inefficiencies. That means you have people coming to site, they're not needed, they have to go off site, so they might get paid, they might not get paid, or the contractor has to move them somewhere else. It just ends up wasting time and also wasting material. So if there are design changes that aren't actually coordinated between the different stakeholders, materials for those design changes may not be needed anymore. So the materials for the wall, if you get rid of the wall, obviously you don't need those materials. Or if the designs change, you maybe need less or maybe need more. So you can end up wasting time and wasting materials. And again, this all adds to cost. If you've got an extra couple of pallets of block work or an extra couple of tons of steel that then the design had been changed and it's not needed anymore, there's going to be a lot of waste, and that's going to add to a lot of things. Overall cost, CO2 emissions, inefficiencies, cost of the contractor, it's just not good. So these are the coordination errors that have a knock-on effect with all materials and labour inefficiencies. And again, if we can eliminate these, the cost savings on the project should be quite substantial. So the following graph shows the BIM workflow, and it's a very useful one to show the advantages of actually using BIM workflow. So we'll see here we have a graph, and we have the effort effect on the y-axis and the different design stages along the x-axis. So we have PD, which is the pre-design, SD, which is your scheme design, DD, which is design development. Then we have construction documentation, which is CD, PRs, procurement, CA is construction administration, OP is operations. So operations obviously is when the building is finished and in use. So if we go on to the first one, you'll see here that the traditional process, most of the effort was actually in the construction documentation stage. So In the pre-design, you've got all your design calculations and you got your scheme design and you got your design development. But it's the construction documentation in this phase is where a lot of effort was going. So that was people producing lots of AutoCAD drawings from different disciplines. You got your mechanical, electrical, plumbing, structural, civil drawings, landscape drawings. All these were individual drawings done by individuals, individual teams, working together, but obviously on separate models. And again, there was a lot of effort here. And yet these all usually had to be printed off a lot of the time and then brought to site and then managed. So a lot of the effort was in this stage here in the construction design, in the construction documentation phase. If we go on to the first bit of the graph, we'll see next is the ability to control costs. So what this means is obviously the higher up on the graph it is here, it's much easier to control costs in the pre-design stage. And as further along the project goes, the harder it actually is to control your costs. So we see here at the very start, the ability is up really high. That means that if any design changes can actually be done quite cheaply, because that's obviously done for anything built. It just involves changing your design, the model, or put on paper, whatever it is. So it's much easier. So, but the further along the process you get, the more effort it actually is involved. And then if we bring in this next curve, this is the cost of design changes. And again, this runs basically the opposite of the ability to control costs, which makes sense. So the earlier on in the project is the cheapest time to actually adjust the design. So obviously if it's easiest to change any design at the start, that's when it's going to be the cheapest, because again, we're just doing this on computers, on models, so there's nothing on site, there's no materials yet. But again, as the projects get together, they're going to start coalescing, and then there's going to be a point in the construction document phase where they intersect, and that's going to be a problem area, where all of a sudden the cost of design changes are actually going to be a lot higher than would have been previously if they've done earlier in the project. So with the BIM process, we see this brings in a new curve. This actually shifts the major effort from the construction document phase over into the scheme design phase and into the design development phase. This is because a lot of the stuff has actually been done before. A lot of the work has actually been done almost before the work starts getting really heavy duty on the site. So again, you're working on these models, and you can see all the issues that are going to pop up. You can do all the changes here, and then this stuff can actually be addressed later on in the process, but it's going to be a lot cheaper to do because all the design changes are done before you get issuing construction documentation and you go to site. And again, this shifts the effort over into the earlier phase. And again, with the BIM process, you can see it's much closer to it's on the right side in terms of cost of design changes, and it's also much better in terms of ability to control costs. If you think about it logically, if you went over to the OP stage, the operation, or even the construction administration stage, you'll see the ability to control costs is quite low, and the cost of actually any design change is going to be quite high. So imagine you had a building that's like 2/3 complete, and all of a sudden there was a major design change. The effort and the cost involved in that design change would be immense, especially if the majority structure is almost there. But if this change can be done much further on in the design process, like in the scheme design phase or in the pre-design phase, it's so much easier, so much cheaper. You're not knocking down walls that have already been built. You're not wasting materials. It just makes everything much more efficient, better coordination, a bit lower costs. So this is why we want to move towards the BIM workflow. One of the key things we've been talking about so far is the cost savings and the increased efficiency of using BIM. And this ties into a general trend which has been seen in the construction industry over the last couple of decades. So here we have an article from think.ing.com. It mentions that it discusses the lagging productivity in the construction industry, which is driving up building costs. So let's quickly go through it here. So the construction labour productivity has fallen over the past 25 years, and other studies say actually it's been falling over the last 50 years. But this has made construction sector relatively more expensive than manufacturing, and labour shortages remain quite high. So obviously, less productivity will result in higher costs. So this is an interesting article, and I recommend you have a little read through it. The link will be on Brightspace, but just taking a snapshot of one of the issues that are relevant to us. This is a paragraph about halfway down through the article. It says, the other way to increase productivity is digitalizing the construction process, with digital tools streamlining the construction process and making it more efficient. For example, providing information to all departments and chain partners can be greatly improved through digitalization. Mistakes are also more likely to be avoided as a result. Managing separate information flows to colleagues and subcontractors can be automated with digitalization so that all parties involved are constantly and automatically informed of the latest adjustments. That is basically what we've been saying in the previous slides. Better coordination can actually improve the productivity. So productivity has been decreasing in the construction industry for the last 25 or 50 years. Using tools like BIM and bringing them into the construction process will improve this, will address these issues, and then in theory could bring down the costs, which are quite volatile to geopolitical issues, labour shortages and all a range of other things. But bringing in digitalization such as BIM tools should help alleviate some of this at least. One of the main advantages of actually using BIM tools, and particularly what we're going to be using Revit, and then next semester it's going to be Navisworks, is to avoid fails and clashes. So we'll see here there are kind of some quite extreme examples, and again, I think the two bridges not lining up or the stairs going up to the ceiling, I'm not sure exactly how real these pictures are, but they're famous ones going around. The one on the left looks like it's a walkway with the structural elements going through the walkway. That looks pretty real, and it's obviously got some significant issues. You can see that when it goes back to our BIM workflow chart a few slides ago, the chances of the cost of actually addressing some of these issues after they've been built would be significantly high. Obviously, these clashes might have been detected earlier on if we use the BIM process using Revit and then a software called Navisworks, which we'll use next semester. We can actually bring in different models, so architects models, things for example, bring them together, and the software will actually let us know it before we go to the building site if there are any clashes. So again, getting these clashes early on in the design phase or the design process is a lot cheaper than actually building something and then going, oh no, we've got a big load of steel in the middle of our walkway, we're going to have to take that down. These are obviously structural elements, and the cost could actually completely snowball out of control for doing this. So in this slide, we can actually see a kind of output from that software called Navisworks we're using. So conflicts and interfaces between different components and different design teams can be identified and resolved through the use of this software. So we'll see here on the left-hand side, we've got a structural model and we've got a plumbing model. And obviously we put the two models into Navisworks, and then it's detecting that there's obviously a pipe going through an I-beam. So this is an issue. And again, this can be detected on the model as opposed to actually on site. A lot of time in the olden days, probably happens nowadays too, you'll see these issues on site where things are hitting each other and you have to cut holes left and right, and that can affect the design. On the right hand side, we can see two sets of piping going through each other again. Again, this can all be picked up in the pre-design or the scheme design phase by the engineers through using their Revit models imported into Navisworks, comparing that with the other models from the other disciplines and just seeing what's clashing and what's not working. Again, getting this stuff early is key to keeping costs down and making the process more efficient, and going back to our previous slides, improving the productivity of the construction process. So next we're going to look at just two terms that are important in terms of BIM documentation. So these are things you're going to come across if you end up working in BIM. So these are going to be the employer's information requirements and the BIM execution plan. So the first one we're going to look at here is the employer's information requirement or exchange information requirement. So the EIR is a pre-tender document, and it sets out the information to be delivered, standards and process that the supplier should adopt during the construction and delivery process, and is always provided by the client themselves. These are then sent out to the contractor, and the contractor can have a look at them and then tender for them and put in a price and see if they get selected. So we will be looking at the EIR in more detail next semester, but just to give a quick overview, and the benefits is probably a useful way to start. For the client, it'll actually create a realistic and information-rich digital twin, which guarantees them a real vision of the project and allows them to evaluate a series of factors, including the construction phases, resources, costs, time, management, and the maintenance process. Again, knowing all these in advance and getting them information from contractors will actually just make the whole process much more productive. So the final thing we're going to look at is a BIM execution plan, or a BEP. So a BIM execution plan is a document or a resource that outlines how a project team will use BIM workflows, tools, and techniques to achieve the desired project outcomes. So why do we need a BIM execution plan? It's basically an essential tool for any BIM project because it helps us set clear goals and coordinate all the different aspects of the project. It should answer critical questions like what BIM software will be used and who is responsible for the different tasks. As we saw earlier on, there are lots of different types of software that can be used in the BIM process. Revit is just one such tool. Companies may use different tools themselves or different software, so getting this all out at the start of the project in your BIM execution plan can help make the process much more productive and much more efficient. So again, these would all be set out in the BIM execution plan. Again, there's going to be links on Brightspace to where you can actually look in more detail, but we'll cover this again in maybe another class or maybe next semester. Okay, so thank you for listening. We've covered all the introduction to BIM theory. There's extra resources on Brightspace as mentioned throughout the video. Please make sure you watch this and get familiar with the different terms and the documentation and the processes, because this is going to be useful for all your projects going forward. Thank you.